All right, we're starting chapter 8, and we're looking at quadratic equations. We're going back to them, and we're going to learn some new methods on solving. So let's revisit the definition. A quadratic equation takes the standard form ax squared plus bx plus c equals 0. Examples are listed here. It is important to notice that the power is 2. So which of the following are quadratic equations? Is this one? No, because it's built with two different variables. Is this quadratic? It is. It has a power of 2 and all the same variable. Is C a quadratic equation? It is. Is D? D is not considered quadratic because it has a power of 3, larger than power of 2. So if we look at the two that we circled, which is already in standard form? So if we look back to standard form is equal to 0. So the one in standard form would be B. Now we already know one method to solve a quadratic equation. We have used factoring back from chapter 5 to solve a quadratic equation. Now this method will not work for every quadratic equation because some, we're going to find, are not factorable. So this method will not always work. That's why we're going to learn some new methods in chapter 8. But let's just revisit how to solve a quadratic equation by factoring. You first want to set this quadratic equation to 0. So you'd move 9x minus 4 to the other side. So you would get 2x squared minus 9x plus 4 equals 0. You then will want to factor that using your factoring techniques. So we would say 2x times x would be 2x squared. A plus on the end means the signs are the same, both negative, and then we need to multiply to 4. Well, you can use 2 and 2 or 1 and 4. Now we can't choose 2 and 2 because 2 can't go with 2, so we have to choose 1 and 4. 1 has to go here and 4 has to go here. If we check our outside and inside values, we have -8 and -1, which is -9. Now to continue solving, you set each factor equal to 0. So this is x is 1/2, and this is x equals 4. Now we're going to pick up and learn a new method for solving quadratic equations. So the method we're going to learn right now is learning to use the square root property. So here it is pretty much in the box. If you have x squared equal to k, then x will equal plus or minus the square root of k. Or if you split that out, you get positive square root of k and negative square root of k. So said in words, what the square root property is doing is if a variable is completely contained as a perfect square, you can take the square root of each side, because when you take the square root of a perfect square, they cancel each other out. Right? So we're going to learn how to do this property. So if we look at problem 1, we can see that the only place I see the variable x is within the power of 2. So I have my variable contained in a perfect square. So I get to take the square root of both sides. Now it's very important when you take the square root to physically put in plus or minus, because a quadratic equation will have two answers. And when you're using the square root property, the only way to find those two answers is by showing plus or minus. Now, it says here that we might have complex answers. That means answers that involve an imaginary value. So the square root of a square will cancel, so we get x minus 5 equals plus or minus. Now this negative under the square root I'm going to take out as an I. So I'm going to get plus or minus I root 3. I'm going to add my 5 over because I want x alone. When you add the 5 over, put it before the plus or minus. So you're going to write 5 plus or minus I root 3. Now there are two answers here. If MATLAB doesn't have a plus or minus key and you have to type them into MATLAB separately, the first one is x is 5 plus I root 3, and the next one is x is 5 minus I root 3. You just take the positive for one and the negative for the other. And those are your two answers separated apart. Now if we look at problem 2, we can see the variable x with a power of 2, but it's not sitting all here alone like this whole expression was. So we have some initial work to do. I'm going to add my 200 over, so I'm going to get 5x squared equals 200. I still want this x squared alone, so I'm going to divide by 5, and that's going to move this to x squared equals 40. Now I have the variable as a perfect square, so I can apply the square root to both sides, remembering plus or minus. The square root of x squared becomes x. This is plus or minus, and then as we learned in chapter 7, radicals must be simplified. So I have to think about what to do with this square root of 40. So the square root of 40 could be 4 times 10, and then I can take the square root of 4. I get x equals plus or minus 2 square roots of 10. Again, if you need two separated out answers, you have 2 square roots of 10 and negative 2 square roots of 10. If you look at problem 3, I have identified the variable x all within the power of 2. So I'm immediately ready to apply the square root. So I'm going to take the square root of 6x minus 1 squared equals plus or minus the square root of negative 8. The square root of this square becomes 6x minus 1 equals plus or minus, I'm going to take out an I for the negative under the square root, and then I'm going to think about 8 as 4 times 2. The square root of 4 is 2, so I'm going to write a 2 in front of my I. So I have plus or minus 2I root 2. Now I need to work on getting x alone. So I'm going to add my 1, and I get 6x equals 1 plus or minus 2I root 2. And then now I got to get x by itself by dividing by 6. And we have to remember they said to write a plus bi for any complex answers. So if we look at this for a minute, the a is separate from the bi. So when we divide by 6, this expression cannot share one denominator. So when we divide by 6, we divide each piece here individually by 6. So we get 1/6 plus or minus. This right here, this 2/6 is going to reduce. So I get I root 2 over 3. And there are my answers. So again, if ever you are working on solving a quadratic equation where an I comes in, and you have to divide to get the variable alone, you must divide each of these pieces individually. They may not share one denominator.